So just as you would immediately stop whatever you're doing if you heard a fire alarm and go and deal with it, we can have the Arduino do the same thing. The fire sensor would trigger an interrupt, which would cause the Arduino to stop whatever it's doing and jump to some other code known as an interrupt service routine, or ISR for short. Now, some of you may be thinking something like, wow, that's a great idea, but how do we get back to what we were doing before the interrupt was triggered? Good question. Just as you would go back to what you were doing if you found that the fire alarm was a false alarm, or were able to easily contain the fire, the Arduino can do the same. It simply picks up where it left off after the code in the interrupt service routine, or ISR, runs. And we'll talk more about exactly how this happens soon. Right now, I just want to go over the concept of what an interrupt is and how it works from a high level. So now we know what an interrupt is, let's talk a bit about what we've been doing in our code until now. What we've been doing is polling, or going through and executing each line of code in order. So, if we were polling a sensor, that simply means that the code checks it over and over again every so often to see if anything has triggered it. This would be analogous to your getting up every minute to make sure the toaster hasn't caught fire. Yeah, it works, but it's inefficient, and what if you're 30 seconds late? Then you have an even bigger fire to deal with. And for your home automation system, polling may look something like this. First, it does a check temp function. Then it goes to the check blinds function, and so on. Then the whole thing repeats over and over again. The actual code in these various functions may have lines that resemble this code snippet. Though code like this would work and compile, there's a few issues with it. We've already mentioned safety and efficiency, but what about situations where safety isn't an issue and our sketch is short, so we don't really need to worry about efficiency too much? Well, if the button press was really quick, like before the Arduino had a chance to get to this section of code, or right after it finished this section of code, the button press could come and go before the Arduino even had a chance to realize it was pressed at all. Now, our lives may not be at stake here, but our project may not behave as expected all the time either. Okay, so now we know that polling and sequential program execution can work fine in some instances, but sometimes using interrupts is the way to go. Let's quickly talk about the two main types of interrupts. There are internal interrupts and external interrupts. Internal interrupts are triggered inside the microcontroller and are caused by things like timers and counters inside the chip itself. So when a timer in there hits 0, that may trigger an internal interrupt so some other high priority event can take place before whatever line of code that would come next is executed. External interrupts are triggered by things like button presses and can also be triggered by sound, light, and more depending on the sensor and the situation. These types of devices are often connected to pins 2 or 3 on the Uno. But note that all pins are interrupt capable, but it's just easier to use pins 2 and 3 for reasons we'll discuss later. Alright, so now we have a solid introduction to interrupts. Before we wrap up, let's do a quick review. There are two main ways to write code. We can use polling and/or interrupts. Interrupts stop the micro from doing what it's doing to attend to a higher priority task. Polling really just means executing code line by line in the order it was written. When dealing with sensors, polling refers to checking a sensor every so often, over and over again, at a repeated interval, to see if it was triggered. Interrupts can be more efficient and safer in many instances, and the two types of interrupts are internal, caused by things inside the microcontroller chip, and external, which are caused by things connected to the microcontroller. Okay, so that about wraps things up for this lesson. In the next lesson, we'll go into more detail on interrupts and using them. See you there.